Hi, I received this package from E3D today. I was very surprised at just how quickly this arrived. I think it shipped and arrived here in like 2 days. And it was only like $13 shipping, so all the way from Great Britain. Let's open it up and see what's inside of here. E3D online. Okay, let's look in the box. A couple of Prusa specific heater cartridges. A couple of Prusa specific thermistors. Some PTFE tubing. And in here should be the good stuff. Extra nozzle 0.4. Extra nozzle 0.4. So one of these will be a plated copper nozzle that I ordered, and the other will be a Nozzle X. Would have been nice if they'd have labeled them. We've got two heater blocks. This one here, I believe, is the copper one. Noticeably heavier than that one, which is the aluminum one. I've got two heat breaks. I will bet this is a Prusa specific heat break, whereas this one is the titanium heat break. I have some collet that go in the top of the heatsink. I have some collet clips. I don't know if the collet clips will actually fit, but we're going to find out. I have a heatsink. Look, and it actually came with a collet and a collet clip in it already. And I have some socks. And I have the E3D Nozzle wrench. Pretty simple wrench, but it was only like $1. I'll probably just use a socket and stickers. Always stickers. Okay, I'm going to take a look at all these parts under the microscope. I've got kind of a clunky setup here where I've got a camera mounted on my microscope, which hooks to a TV. It's the TV over here, and then we're recording the TV picture on my DSLR. So hopefully this is going to work out all right and stay in focus and everything else we want. Apologies if it's a little bit off, but I haven't figured out a way to record directly from the microscope camera yet. So this first heat break here, this is the Prusa specific heat break. You can tell because you can see a little step. There, you should be able to see it like right there. Right near the end of the heat break. So that's what makes difference between a Prusa specific heat break and a normal heat break. That's something to do with the MMU2. I don't have an MMU2, so I don't really care. But anyway, there is a heat break. And then let me look at the titanium heat. Let's look at the titanium one. So the titanium one, you know, it's hard to see, but I can clearly see that there is no little step down near the end of it. So that shows you this is not a Prusa specific heat break. But anyway, you know, to the naked eye, the two of them look pretty much the same. The Prusa specific stainless one is in the baggie. Titanium one here is in my hand. The real difference is going to be when we go to try printing. Now looking at the heater blocks, I've got both of those here, so there is a noticeable weight difference between the two, so it's very easy to tell which is which. Plop out the aluminum one. There is aluminum. And this. Here are the two heat breaks side by side. This one here is the aluminum, this one here is the copper. I'll put them on the scale in a moment, but there is a dramatic weight difference between the two. It's very easy to tell the difference. Copper one is much heavier. You may not be able really to tell on the microscope, but it is a lot shinier, and it's got a slightly different hue to it. It's also got a logo down there. But yeah, big weight difference, and the plating gives it this kind of shinier color. Again, you know, the proof is going to be in when we go to print with it, you know, how different the printing experience may be. So we've also got some nozzles here. I can tell which one is the Nozzle X because it is a hardened steel and it is magnetic. The copper one, of course, not magnetic. Let me see if I can get you in focus right on the tip of the nozzles. That seems pretty close to in focus there, so you can kind of see the how well the circularity is on the holes. I'll see if I can actually zoom in on that. Bear with me here while we zoom in. Okay, there, so now you can see close-ups on our two nozzles. So we've got some complaints online about the Nozzle X not being well-rounded. It does look well-rounded to me, though if you have it at an angle, it'll kind of look oblong. That's kind of what E3D was claiming. I swear to me, visually, the copper plated one looks smaller than the Nozzle X, even though they're both supposed to be 0.04 millimeter. Maybe it's my imagination, maybe it's a trick of the light. Let me count the little dots on them. 1, 2, 3 dots on the Nozzle X. 1, 2, 3 dots on the copper. So same number of dots, so they are the same size. Sides of the nozzles, and let's see if we can look down from the end. Kind of hard to hold them up here. I think I see some like plating material around the tip. Maybe it'll just wear out itself in time. Here is the Nozzle X. Take a look at the heatsink. It's your typical aluminum E3D heatsink. Nothing special here to see. It does have collet and collet clip already mounted in the back. So let's compare the weight difference between the two heater blocks. Here is the aluminum. On my postage scale, it's weighing in at 0.2 ounces. If we take the copper, weighing in at 0.8 ounces, so approximately 4 times as heavy for the copper heater block. Okay, so it's time to assemble the new hot end. I'm going to talk a little bit about the choices that I made first, since I did buy some premium components here. So as you can see before, I did buy some extra stuff. I bought, both the titanium heat break and the standard one. I bought both the copper heater block and the standard one. But my intent was for those others to be spares. My primary stack here, let's actually put it in order, it's going to be the Nozzle X, the copper heater block, the titanium heat break, and the aluminum heatsink. So starting with the Nozzle X, why did I choose that? Well, my thinking there was I do want to print some abrasives, and you need a hardened nozzle for that. E3D claims that this is like the one nozzle to rule them all. It's got all kinds of nice features on it. It's hardened steel, it's also plated, it's also got I think it's like an oleophobic coating which will resist stuff sticking to it. The one thing that it probably doesn't have is the greatest thermal properties, because it's still going to be a hardened steel nozzle. It's not going to have as good thermal properties as brass has. So we'll see whether this really is going to be the one nozzle that can do everything I want, or whether I still end up swapping out to something else like that copper plated nozzle or a brass nozzle. The copper heater block. There were a couple reasons I went with this. It is higher temperature, so you can run higher temperatures. You can print fancier engineering filaments. I don't know that I really want to do higher temperature. My thinking with it is that it's probably more durable than aluminum. It also has much greater mass, and I believe it has better thermal conductivity than aluminum. So all those properties should combine to be helpful. I have read specifically that people using the Nozzle X together with the copper heater block have a better experience than people using the Nozzle X with an aluminum heater block. The titanium heat break, this has two advantages to it. One is lower thermal transfer. You actually want the heat block to stay hot on one side and as cool as possible on the other. Titanium is supposedly I'm not sure I'm using the right terminology here, but I believe what I read is that it has lower thermal conductivity than stainless. So less heat is going to creep up from the nozzle into the heatsink, which would mean less to cool at the heatsink. At least that's my thinking and what I've read. I have read some complaints on this that they actually get more jamming with the titanium due to its properties of being cooler up in here. Maybe the filament cools too much or something. So I don't know. We'll see. I'm hoping that it does in fact turn out to be a plus rather than a minus. The other advantage to titanium is that it is harder than stainless. So you read about people who, when they're changing their nozzle, they put the wrong kind of torque on the heater block when they're trying to unscrew a nozzle, and they snap their heat break. So I'm hoping, titanium, less likely for that to happen. If the nozzle collides with a print, less likely to break the heat break. That's my thinking, at least. One of the disadvantages to a harder material is that if this ever does get broken and it gets stuck in either the heater block or the heatsink, if you've ever drilled a hardened bolt out of something, you realize that it can be very hard to extract hardened materials. We'll see. Hopefully it'll never get broken, and hopefully if it does get broken, it won't be the devil to extract. And then of course this is just the standard heatsink. Nothing special there. So let's try to put some of this together. Oh, I forgot to say the other advantage to the copper heater block is that it is plated with this, I believe it's nickel, and that is supposed to stick less to plastics. Specifically PETG is not supposed to stick real well to it. And that would be advantageous to keep PETG from getting stuck all over everything like PETG likes to do. I'll probably still run it with a sock, standard socks. I'll probably still run it with those because the sock provides some thermal insulation and it provides kind of a first layer of defense against filament sticking to stuff. Now, one of the disadvantages of a sock is they only go up to a certain temperature. So if you do print high temperature materials, you can't use a sock, and then it becomes real advantageous to have the plated heater block. So let's assemble this. Now, I've looked at several guides online and watched several other videos on how to assemble it. It seems pretty simple. We will start screwing in the nozzle. Now you actually want to take the nozzle and you want to unscrew it between 1/4 and 1/2 a turn. So I'm going to give it a good half. And then you take the heat break, the small end goes in. You screw them in until they touch. Then you can tighten it down. Now this is the nozzle spanner I bought from E3D. A socket would also work fine. And I would probably use a socket when I go to hot tighten this. So this is not the final tightening. The final tightening we will do under heat. Now I saw in E3D's guide that they do recommend using some thermal paste. I happen to have some Noctua NTH1 thermal paste. You put it on the cold end of the heat break, you don't put it on the hot end. Let's apply just a little bit of this. Now the goal, I think, is probably not to end up with thermal paste all over everything inside of the heatsink. Let's just try to work some of it into those threads. Probably a little bit goes a long ways. And then we can take and screw our heatsink down over the top. There we have it. Now we have a couple screws that need to go in this. Looks like they gave us some spares, so one of these is going to go back here to secure the heater. The other one will go in here to secure the temperature sensor. For my actual install, I'm going to try to reuse the heater and the thermistor that are installed in the printer right now. I don't know how well that's going to go, because that stuff could all be stuck in there hard, and the leads could be brittle. But that seems easier than rerunning all this wiring. But for now, let me try test fitting, just to see, does fit in there? It does. You'd want to kind of center it up. And let me see just how much you need to crank down on this to tighten it down. I've heard you have to crank down pretty hard on the copper block, but really not. I mean, it's quarter turn on that screw is enough to tighten it up. That's good. Hopefully the other one will come out as easy as that one goes in. And then the thermistor. Just to check for fit. And I understand this, you tighten it up till you feel it touch. Just right there, and then you'd give it another quarter turn. I'm not going to give this one a quarter turn because there's no need to kind of crinkle this one in at all by tightening down on it until we're actually ready to use it. But that's what we do. And then the sock will go over the end like so. Okay, next up is to prepare a PTFE tube. I've already beveled the end of it using this tool I got on Thingiverse. So I took my X-Acto knife, put it in this slot, and then you take and you run your tubing and you kind of slowly push it in and turn it until you get just a little bevel on the end. It's 45-degree bevel. I've already done it on this one. Then we take this jig here, which cuts it to length, like so, insert it full length. We're in all the way. Cut. Now we've got it beveled on one end. We need to chamfer the other end. These things here, which are center drills. So let's find one that is the right size. That one seems pretty close. A little too big. Probably this one here. So this is going to put a 60-degree bevel into the inside end of this tube. We're just going to look at it. And it's pretty close. Just give it a hair more. Okay, so now we've got 45-degree outer bevel there and a 60-degree inner bevel here. It's time to insert this into our hot end. Kind of wish it was straight. Maybe I'll kind of force it straight. I assume under heat it's going to straighten itself up. Let's take the collet clip out of the way. I want to make sure the outer bevel goes in. Make sure it's pushed in all the way. Then you pull up on the collet. Then we're going to pull up on the collet while pushing down on the tube. And insert the collet clip. Like so. Before putting this in the real printer, I'm going to test fit it into some of my spare parts. It's kind of a process. Get one of these into there. There we go. I put it in backwards. I think I did. Let's try that over again. So I've kind of made this a devil to get out of there. Kind of work it back and forth a bit. Let's go in that way. Boy, I sure don't like how this thing fits in there. If I can't even get it in here on the bench easily, it doesn't bode well for it to going in. I just put it in backwards. Okay, sideways. Just being an idiot with this thing. Is that right? Yeah, that's right. That is how it's going to go. Just like so. So I went ahead and I installed the new hot end in my Prusa i3 Mk3 printer. This wasn't as difficult as I feared it would be. You know, I remember it being quite a complicated process to assemble the extruder back when I built this machine up back in December. So I was worried I was going to have to tear the whole thing down and redo it all again. But fortunately it wasn't that much work. So I had to take off the part cooling fan. I had to take off this shroud around the part cooling fan. So that's 2 screws. You have to take off the 4 screws over here that hold the heatsink cooling fan on. Then there were 2 more screws in here, there and over here perhaps, that you had to pull out. And then, you know, this black cover piece off the extruder came out. And then I was able to get in there and kind of wedge the hot end out. Now getting the hot end out of there was a bit of work. The way that the Mark III is designed, you have to kind of pull it out at an angle and rock it, and it kind of took a little bit of work. I was also able to get the heater and the thermistor out of it. I had to do those while it was heated up because those things were stuck in there pretty tight. So I heated this up to, maybe like 250 degrees. Then I was able to loosen the 2 screws on the bottom that hold the thermistor and the heater in. Then I was able to push the thermistor and heater out of it. And then I was, able to get the hot end out, put my new hot end back in, and reverse that whole procedure, secured the heater, thermistor, put it all back together, put the sock on it, and then I did a PID auto tune, to get the temperature tuned on the new heater block, and then I reset my Live Z. After that we were good, so I printed several prints with it, and we'll go over those in a moment to get a look at the print quality that came out of this. The other thing to judge about this is because the nonstick coating is one of the selling points of this printer is, how good does that nonstick coating work? I'll see if I can get up there with the camera and take a look at it. Okay, I'm not certain how easy it is to see this. Let me move the camera around a little bit so you can look at it. But you can see there is some white PETG stuck to the nozzle tip. That won't come off while cold. I mean, I've tried prying at it with my fingernail or kind of poking and prodding at it with the tweezers a little bit. It does, when it's cooled down, it does seem to be stuck on there pretty hard. But as soon as you heat the printer up, that PETG does seem to pull right off of the non-slip coating on the nozzle. So is that better than it used to be with my old brass nozzle? I think it kind of is, because the brass nozzle, I would notice more stuff kind of burned onto it and, very crusty and difficult to get off. Where this thing, it doesn't seem to have really been accumulating burned on crud. And what is on it does seem to pull off really easily when it's under temperature. So on the left side we're going to have before I upgraded, and on the right side will be after I upgraded. So this is the old one, this is the new one. This is PLA, Amazon Basics Purple PLA. These are the bottom surfaces, and here are the top. This was just a 4-layer square that I downloaded on Thingiverse. So it's 0.8 millimeters thick maybe, and printed at 0.2 millimeter resolution. Now I do see a little like bumpy spot there and a bumpy spot here. Just a couple imperfections in the surface quality. I don't really know exactly what happened to that. They weren't present on the original, though the original does have some rough stuff here near the edge. Just this little surface imperfection there and there. I'll have to actually watch sometime when it's printing and see if I can tell how something like that happens. Okay, next up we have a couple calibration cubes. Again, here's the old one, and here's the one after the upgrade to the Nozzle X and other parts. This is the bottom surface. Flipping it over, you can see the top surface. There's the sides, the X side, the Y side. I think these look pretty good. Yeah, I think the quality seems pretty equivalent. Here's a little glitch in the old one, just a little scrap of filament. The X looks like it's in there pretty crisp. The little overhangs on the X look fine. I think the calibration cubes turned out all right. Now we have some frogs. This is Tree Frog. It comes on the Prusa SD card. This is actually the third print I ever printed on my printer. I printed this way back in December. It's the third thing I have ever printed on any printer. I think Tree Frog is a good test because it does have some delicate spots here up around the arms, and it's got some overhangs and stuff like that. So this is, like I say, this is quite an old one here. You can see on the bottom, this is before I really dialed my layer heights in, so my layer height was a little bit off. This one I had my layer height in a lot tighter, so it's very, very smooth. But I would say the quality on these two Tree Frogs is approximately equivalent. The wife looked at this one. She says this one is shinier, and I can kind of see that when the light hits it. It does have a little bit of a reflective shine. Whereas this one, he seems a little duller. But again, the filament, this was printed 4.5 months ago. So the filament's been sitting that long, the print has been sitting that long, so maybe the difference in shine is due to just differences in the thing sitting out. You can look at him from underneath. I think he looks fine. I had a little bit of trouble detaching the brim from this one. Maybe that was just the tightness of my layer height. I had to kind of cut the brim loose because it wouldn't just pull loose. But you know, the underside is good and smooth. You know, there are some jaggies, like up here, you know, where it had to do these little overhangs, but it's the same amount of jaggy stuff on both of them, more or less. So I think Tree Frog was a success. So like I said, this was actually off the Prusa SD card, and this was G-code. So certainly I have not changed the temperature settings or the extrusion rates or the retractions or anything. So other than doing a PID calibration and a live Z adjustment that you have to do whenever you change a nozzle or a heater block, none of the other settings did I change. So we're printing exactly the same settings as we did before. So that's it for what I did in PLA. So we do have some PETG. So here we have some PETG octagons. These are single layers, 0.2 millimeter layers. This is the underside. Flipping them over. There's the top. Again, exact same temperature, extrusion rates, everything else between the two. I think turned out fine. It does feel like I've dialed in my Live Z a little bit tighter on this one. This one here is a little, feels like it's a little rougher. This one, the top layer, is a little smoother. But I think the single layer tests worked out fine. Here are, this is the 4-layer 75 millimeter square. Old one here, the Nozzle X one over here. The square turned out fine. There's a little rough spot on the corner, but that rough spot is actually on each of them. So nothing really has changed in printing the square. Calibration cubes and PETG. Again, we have the old one over here, the Nozzle X one over here. Let's line them up the same way. Come on, there we go. There you can see the top. They look pretty much equivalent to me. And both of them, the X seems to be cut into there good and crisply. They seem fine. I have a couple of micro all-in-one 3D printer tests. Now, unfortunately, these are printed in different filaments, different colors. The orange one I printed maybe a month ago in Amazon Basics Orange PETG, whereas this white one is in Amazon Basics White PETG. The orange is the old setup, and the white is the Nozzle X, the copper heater block, etc. So here we do see some differences. So there's some rough stuff kind of up here on top of this overhang at the between the 50 and 60 degree marks. There's some crud here that just kind of left hanging there. More interestingly, there's this, if I can get it out of there, get it? Get my tweezers. There's some kind of brownish, slightly burned looking extruded stuff just kind of laying around in there. It wasn't adhered to anything, so I would guess that, you know, maybe this was something that dripped off while we were doing these overhangs and just kind of fell in there. Yeah, this came out kind of rough. You know, here we are again at that 50, 60 degree mark. The overhangs are kind of tough for it. You can look on the back of this one. This is the old one. It's rough too, and it's kind of rough in similar spaces. The orange one did have a lot more crud on this this edge here on this overhang. This one seems to have less crud, but it's got more crud there. So here where these bridging tests happen, the bridging tests all seem to have succeeded. No problems with the bridging. On the old one, the bridging also succeeded. It looks to me like there's a little more stringiness in the old setup than in the new. Let's get that crud out of there. The circles went in fine. These pillars on the sides, I'd say they're largely equivalent between the two. So, I mean, if I had to say, I would say the new one is a little bit rougher than the old one, but not a whole lot. So these here are some LED cob panel brackets that I've been working on, something I designed in Tinkercad. The old one is up here. You can see it's got some heat set inserts that I put in it when I was working on it. Now they are different sizes. The new one is smaller than the old one, but that's because of my revision to the model. That's not a printing issue. But just looking at the print quality, I mean, they both printed structurally sound. This is the new one down here. There are some stringies, a couple little stringies there, some stringy stuff there. Bottom side looks fine. The surface finish on the top, I would say, is mostly equivalent. Yeah, I mean, it's hard to find a difference. These are printed in 0.3 millimeter resolution. There is a little string of something here poking out the side. It's not actually some of the filament that got... so it's not actually one of the layers that ended up shifting. It was just a little string stuck to the side of the model. Yeah, I would say, you know, when I see something like a little dollop of PETG there, there's also the same one here. Not a whole lot of difference between these two. I also printed out another couple pieces. These are both with the Nozzle X. I don't have one to show of these for the old setup. Now there is some of this burned on stuff over here on this side. I kind of wish I'd have been watching this to see, you know, exactly what happened. It just pulls off there so it's not stuck on. But here, down here on the bottom, something bad must have dripped or oozed onto there when it was doing the first layer, but I wasn't watching. Anyway, these prints are mostly pretty good. A couple little filament strings here and there. This one's pretty good. Got a little bit of warp into it, but PETG, it just seems to like to put a little bit of warp into stuff. Okay, bonus material time. While I was editing the video, my roll of 3D Solutech glow-in-the-dark filament arrived. That was one of the things I wanted to print with the new Nozzle X, because this filament has strontium aluminate particles in it, and it's supposedly somewhat abrasive. So just in time it showed up, and I was able to print another tree frog. So here he is. He's still on the build plate. Let's see if we can pop him off. There, he's off. I haven't taken the time, obviously, to get the brim loose from it. I'll probably have to take my knife and cut the brim away. It's interesting. This filament is somewhat transparent. I can see right through. I mean, I can see the infill structure in there. So this is cool material. I think this is. I'm just kind of looking over the print. You know, it came out pretty smooth. Again, there's a little bit of roughness here and there. It's a little dollop of crud here over the eye that I could probably trim off. Well, I got it off with my fingernail. There's a little bit of stringiness there. So let me turn off the light, and we'll see if the camera is able to pick up the glow. There we go. It can actually see it. Cool. Now I also printed, before I did the frog, just to test the first layer, I printed out one of those squares, the 75 by 75 Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.